Hello everyone. This is a course to learn the basics of C programming language. Today's topic is Introduction of C language. The table of contents of the class is as follows. First, we will study what C is, specifically the pros and cons of C, the process of C programming, and the basic form of C programming. Secondly, we will learn about C data types and end the class with practice. First, let's look at the introduction to C. A programming language is the language for writing software that drives a computer system. These programming languages are largely divided into low-level language and high-level language. Low-level and high-level languages are not good and bad languages, but are relatively divided into whether machines are easy to understand or people are easy to understand. C programming language is a programming language available on almost any computer system currently in use. Programs written in C language have the advantage of being portable to various hardware. In addition, because it is a procedure-oriented programming language, the code is relatively easy to maintain because it is not complex and the code is simple, so the finished program is small and runs fast. It also has the advantage of controlling hardware because it has the characteristics of lower-level languages. At the same time, however, it has the characteristics of lower-level languages, making it harder to learn than other advanced languages, and the system resources can be controlled directly, so you need to be more careful. Programming refers to the process of writing a specific program using a programming language in an algorithm with a purpose. Programs created in this way must first be converted to executable files before they can run. This time, we are going to talk about the process of generating executable files from programs written in C. The first thing you need to do in programming is creating a program. A program that is logically written in C is called a raw file or source file. Source files created in C have an extension of .c. Next, source file is pre-processed by a preprocessor. Preprocess refers to the processing of preprocessing instructions that begin with the preprocessing character in the source file. The preprocessor does not generate code, but only reconstructs the source for the compiler to work better before compiling. The preprocessed file is then compiled by the compiler. Computers can only understand machine words written in binary numbers of 0 and 1. Because the source file is written in C language by the developer, compiler converts it into a machine language that can be recognized by the computer. But object files generated by the compiler do not have a startup code. Also, C standard library files are not included. So, linker combines one or more object files, startup code, library files into one file. This step is called link. At the end of the link, a new executable or library file is created. The source file is converted into an executable by a preprocessor, compiler, and linker through the above process. Most recent development tools include the preprocessors, compilers, and linkers introduced above, so they generate executables from the source file at once. The executable files created in this way has an extension of .exe. Now we are going to look at the form of C programming. The example on the left is the simplest form of C programming, which is an example of outputting "Hello World." It is not necessary to understand every part of the code yet. However, you can see that the code is in the function named main. The C program consists of one or more functions. In addition, all programs implemented in C language must have a main function, as in the example on the left. This is because when the program C is running, the computer finds the main function first and calls it. Each statement in the function must end with a semicolon. In the above example of writing a semicolon, you can see that the program ran successfully, but the example below that did not write a semicolon did not run due to an error. This is an important matter that is simple but easy to miss. Comments are written for debugging or descriptions to help you understand the code. Annotations can be anywhere in the program. One-line annotations in C language use // as at the starting position, and multiple line annotations must start with /* and end with */. Now we are going to learn about the two simplest functions of C programming. The function that you use to interact with the program is called an input-output function, or I/O function. The printf function and scanf function are the most commonly used I/O functions among the C language standard I/O functions. The first function is printf, standard output function in language. The first function is printf, a standard output function in C language. The printf can also print a sentence, as it is in the first example, but the format specifier allows you to specify which format to print the data you want to print out in the second sentence. At this point, %d indicates that a variable is the first place to enter, and secondly, the variable must be output in integer form. These are the typical format specifier used in C. So you must select the format specifier to match the type of data you want to represent. Scanf is a standard input function in C language. It allows user to input variable data in different formats. To receive data in C, you must first assign a memory of the size corresponding to the type of data you want to receive. The amount of memory allocated by the program to store the data is called variable. To receive data in C, you must first assign a memory of the size corresponding to the type of data you want to receive. The amount of memory allocated by the program to store the data is called variable. We will learn more about variables in the next section. After declaring a variable, you must first specify which data format you want to enter using the format specifiers you learned earlier, and use the ampersand symbol to specify which variables you want to enter. The ampersand symbol is called the address operator. This address operator means to store the data you have entered in the following variables. Thus, this example is a code that declares a variable called num, and then receives data in integer form and stores it in a variable called num. Also, if there are multiple formatters, the separation of data received is based on spaces, such as line breaks, tabs, and spaces. Therefore, two numbers can be entered at the same time as in the example. This time, we will learn about the data type of C. Variable means the amount of memory that is assigned a name by a program to store the data. In other words, a variable means the amount of memory in which data can be stored, and these stored values can be changed. Variables associated with numeric representations in C language can be divided into integer variables and real variables. Again, integer variables can be divided into char, int, and long variables, and real variables can be divided into float and double variables. To declare a variable, you need a data type and the name of the variable. However, it is best to name a variable to better represent the meaning of the data to be stored in that variable. In C language, you can name variables relatively freely. However, there are rules that must be followed when generating a variable's name for a variable. First, the variable's name consists of only alphabetic characters, numbers, and underscores. Second, the name of a variable cannot begin with a number. Third, you cannot include spaces between the names of variables. Finally, you cannot use a predefined keyword in C language as the name of the variable. Let's understand it more by example. The first example uses special characters, and the second example starts with a variable name with a number. The third variable name contains spaces in the variable name, and the last variable uses predefined keywords as variable names. The variable essentially serves to remember the address of memory. A memory address is a kind of identifier used to distinguish physical memory space from each other. In other words, a memory address means a unique address for identifying an exact location in the memory space. When you reference a variable, you do not refer to the address of memory, but to the data stored at that address. Therefore, variables should remember not only the address of the memory where the data is stored, but also the information about the length and shape of the stored data. The following figure shows how variables are stored on memory. One memory space stores 1 byte of data consisting of 8 bits. Therefore, memory addresses are incremented by 1 byte and data is stored sequentially from low address. This time, we will learn how to declare and initialize variables using the data types and variables we learned earlier. In C language, you must be allocated memory space to store a variable before you can use it. This behavior is called declaration of a variable. You can only declare a variable like the first example, or you can initialize it at the same time as the variable is declared like the second example. Note that uninitialized variables contain only garbage values, which are meaningless values. Constant, like a variable, is a memory space that can store data. Constant, like a variable, is a memory space that can store data. However, the difference between a constant and a variable is that you cannot change the data stored in the constant while the program is running. These constants can be divided into literal constant and symbolic constant depending on how they are represented. A literal constant, unlike a variable, does not have a name that points to the memory space where data is stored. Literal constants can be categorized into integer literal constants, real literal constants, and character literal constants, depending on the type. Symbolic constants are constants with names as well as a variable. These symbolic constants must be initialized at the same time as the declaration. Symbolic constants can be declared using the const keyword or using macros. Data type is the role of explicitly telling how that data is stored in memory and how the programs should handle it. Therefore, C provides various types in advance, which is called the basic type. These basic types can be largely divided into integer, real, and character types. First, an integer means a number that has a sign and has no decimal fraction. The first bit in the memory space of integer is the most significant bit, which represents the sign. When you add the unsigned keyword to integer data, even the most significant bit that represent the sign can be used to represent the size. These unsigned integers will not be able to express negative numbers, but positive integers including 0 will be able to express twice as much. The sign keyword, which can even express negative integers, can be omitted by default from any type. When determining the type of integer data, be sure to consider the maximum size of the data you want to use. This is because if you store data that is beyond the range that type can express, it can overflow, resulting in completely different values. Second, real numbers are numbers with decimal parts or exponents, which have a much wider range of expressions than integers. However, the way a computer expresses a mistake is necessarily limited by the technical limitations of the error. In the past, float type was used a lot to express mistakes, but now double type is used the most due to the increase in memory space due to the development of hardware. Finally, there is a type that can express one character. Computers can only recognize binary numbers, so characters must be expressed in numbers to recognize them. The example shows that the alphabet A is an output as A when it is output as a character format, but 97 when it is output as an integer. The most commonly used of these commitments is ASCII. ASCII is a 7-bit character encoding scheme that uses alphabetic characters. The ASCII code represents character in 7 bits, so it can represent a total of 128 characters. Finally, we will learn about type conversion. The operations between different types in C are performed after all the operands are made of the same type. The act of changing one type to another is called type conversion. Type conversion from a type with a narrow range of expressions to a type with a wider range of expressions is not a big deal. However, in the opposite case, a type transformation to a type with a narrow range of representations results in data loss. Type conversions are largely divided into implicit type conversion and explicit type conversion. First, implicit type conversion is a type conversion that the compiler automatically executes. For assignment operations, the type of data on the right side of the operator is converted to the type of data on the left side. For arithmetic operations, it is converted to a direction where the loss of data is minimized. The first operation in the example shows that int type data is automatically converted to double type data to minimize the loss of data because it is an arithmetic operation of int type data 5 and double type data 3.14. The second operation is an arithmetic operation of float type data and double type data. Again, float type data is automatically converted into double type data to minimize data loss. Second, explicit type conversion is a type conversion that is forced by user using typecast operator. You can add parenthesis bracket before the data you want to convert and write down the type you want to convert. This bracket is called the typecast operator. In this example, the result value of the first operation is 0.000000. This is because the type of result value for an arithmetic operations always matches the type of operand. This means that the results for arithmetic operations between int type data always come from int type data. Therefore, as in the second operation, you must explicitly specify one operand as double to obtain an accurate result. So far, We have completed a brief introduction to C, data types, and studies on variables. Let's finish the class after a simple practice where you can review what you have learned so far. Today's practice is making a program which inputs a number and a character in order and prints them respectively. Let's pause the video and take some time to solve the problem. Did you solve it well? This is a question that allows you to review the printf, scanf, and format specifier that you learned this time. You need to declare a variable because you need to enter numbers and characters first. I would like to store numbers in an int type variable named num and letters in a char type variable named c. After that, numbers and characters are input using scanf, and numbers and characters are output using printf. You didn't forget to write the format specifier according to the data type, right? %d for int type variables and %c for char type variables. This is it for today's class. Thank you for watching.